start talking about solving systems again today, just like we started talking about yesterday. And yesterday we were able to find a solution by looking for where the two graphs intersected on the graph. Today we don't have that option because we don't have the graph. So we are going to solve by something called substitution. And we're going to start by talking about it when they are both in slope-intercept form. So you'll notice y equals negative 6x plus 3, that's slope-intercept. This is a horizontal line, but we're still going to use it. These are both equal to y. So that means I can substitute in negative 3 for y in my other equation. That's legal because they're equal to the same thing. So I'm going to write one equation now, and I'm going to plug in negative 3 for y, my first equation. So I have something like this. Negative 3 equals negative 6x plus 3. Once I have this, now I'm down to one variable, which suddenly my life is really easy. What I'm going to do is just solve for x. So first step is to get rid of this positive 3. Reverse operation of a positive 3 is a negative 3. Negative 3 minus 3, that's negative 6. So I have negative 6 equals negative 6x. From here to get x by itself, I'm going to divide both sides by my coefficient of negative 6. It means I get x equals 1 as my answer. Now, once I do this, I'm going to take this, I'm going to plug it back into one of my equations. Just for the sake of argument, I'm going to plug it into this first one here so we can talk about the process. So we're going to have y equals negative 6, came up with an x value of 1, so I'm going to plug that in for x, plus 3. I'm just going to simplify and solve for y. So I have y equals negative 6 plus 3. If I simplify that, y equals negative 3. So I have my x value, I have my y value. My last step, write it as a coordinate point. So the solution to this equation is 1, negative 3. So if you're looking at this on a graph, that would be the point where our two equations intersect. Let's try another example of this. So this time, we made it a little bit more complicated by adding in two actual equations with x variables. But you'll notice they're both still equal to y, so it's perfectly legal for me to take one of my equations, plug it in for the other y. So I'm going to take one equation now, negative 3x minus 6 equals negative 5x minus 6. Now I've gotten rid of my y, and I'm just going to solve for x. So I'm going to add 5x to the other side. That gives me 2x minus 6, those cancel, and left with negative 6. From here, to get x by itself, I need to add 6 to both sides. I get 2x equals 0. Then I'm going to divide both sides by 2. And we know that 0 divided by anything, that's 0. From here, we need to plug in this 0 into one of our equations. It does not matter which one. So I'm going to plug in this 0 here. So I'm going to get y equals negative 3 times 0 minus 6. Can't access my extend button with this thing here. So this will become y equals 0 minus 6, which makes it y equals negative 6. All I'm going to do from there, write my coordinate point. Got my x value, got my y value, my answer, 0, negative 6. I would like you to try B yourself. Perhaps check an answer with someone sitting near you, or wait for me to get to this to get an answer for it. While you're working on it, pause the video so that I can continue on with our next opportunity here. So in those first two examples, they gave us two equations in slope-intercept form. This time they give us one equation in slope-intercept form and one equation in standard form. So we have to sort of add a step to this. What we're going to do is we're going to take our equation in slope-intercept form. Y is equal to 8x minus 10. And since that's equal to y, I'm going to plug in that whole thing in for y into my second equation. So here's what this is going to look like. I'm going to have negative x plus 6 times 8x minus 10, since that is y, and just plug it in, equals negative 13. Now from here, my goal is to solve for x. So I need to simplify this left side. There's a lot going on. So I'm going to start by using the distributive property. Nothing's going to happen so far to the negative x. 6 times 8, that's 48. So I'm going to have 48x. 6 times negative 10, negative 60. So this is going to be equal to negative 13. Now I'm going to combine my like terms on my right side. So this is going to become 47x minus 60 equals negative 13. Now to get x by itself, I'm going to add 60. I get 47x equals 47. I'll work on this. To get x by itself, I'm going to divide by 47. And I get x equals 1. Once I have my x value, I'm just going to plug that back in to one of my equations to solve for y. Now, it's typically easier to plug it into the slope-intercept equation since that's already solved for y. So we'll do that. So we're going to take y equals 8. My x value I said was 1, so I'm going to plug in 1 for x, minus 10. That's going to give me 8 minus 10, which is negative 2. So I've got my x value, I've got my y value. I just need to write it as a coordinate point. 1 comma negative 2. Again, if we were to graph this, that would be the point where they crossed on the graph. Let's try another of these. So again, actually, we're going to erase this. So if you need to finish writing, just go write and pause the video for a second. I need a little bit more space than I have here. So I have y equals negative 7x minus 8. I'm going to take this and plug that in for y. So I'm going to say negative 3x minus 7. Y is now going to be written as negative 7x minus 8 equals 10. My next step, simplify that left side so I can solve for x properly. I'm going to have negative 3x plus 49x plus 56 equals 10. From here, we've got some like terms. I'm going to combine those. This is going to become 46x plus 56 equals 10. To get x by itself, we'll subtract 56. It's going to give me 46x equals negative 46. So when I divide by 46, I'm going to get x equals negative 1. And from here, I'm simply going to plug this back in to solve for y. And I like to do slope-intercept because that's typically a little bit easier to make happen. So I'm going to say y equals negative 7 times negative 1 minus 8. That's going to become, there's negative multiplied by negative, that's going to get positive. So I'm thinking I'm going to get negative 1 for my y value as well. Got an x, got a y, that means my final answer. Negative 1, negative 1. I'm going to give you a couple more examples. We're going to start solving this just like we did in the last one. I have an equation in standard form, an equation in slope-intercept form. So I'm going to take my slope-intercept form, and I'm going to plug that in for y. So this is going to become 6x minus 2 times 3x minus 2, that's my new y, equals 4. Then just like every other time, we've got to distribute. So I have 6x minus 6x plus 4 equals 4. From here, I'm going to combine my terms on my left side. So I've got a 6x and a negative 6x. And those actually cancel. 6x minus 6x, that's 0. So that leaves me with 4 equals 4. Now, my goal is to solve for x, but suddenly my x is gone. So this has a special answer. If you get a situation where your variable that you've been trying to solve for, I think we're trying to solve for x here, if that cancels out and you're left with just two numbers, you have to decide whether they are true or false. So does 4 in fact equal 4? I'd say it does. 4 is 4. If that's the case, you're going to get an answer, all real numbers, or infinite solutions. Remember, this is the case, we talked about this a little bit yesterday, where the two equations are stacked on top of each other so that they look like one. It's like a double-decker bus. So they don't actually cross ever because they are on top of each other. So every number you plug in will work. Let's look at the opposite end of the spectrum here. I look at example B, and I plug in my slope-intercept form into my standard form. It's going to give me just positive 9x plus 3 times negative 3x minus 2. That gives me 9x minus 9x minus 6 equals negative 2. And just like before, I'm going to combine my like terms before I go on. So 9x minus 9x, those cancel. And that leaves me with negative 6 equals negative 2. Now, just like last time, I lost my variable with that simplification. So I'm left with two numbers, negative 6 equal to negative 2. This is not true. Negative 6 does not equal negative 2. So when you get something like this, where you have just two numbers, they don't actually equal each other, you have a false statement, your answer, no solution. These lines, remember, are parallel lines, so they are never ever going to cross, which means they don't have a solution. You have the rest of the hour to work on homework assignments, get a little bit caught up, maybe work on that project that is due on Monday with the topics for systems of equations. Use your time wisely.